as x approaches infinity or negative infinity, it's not going to make any difference. It's a rational function. From 2x squared plus x minus 1 from x squared plus x minus 2. Can anyone give us the factored form for the denominator?
That's x plus 2 and x minus 1.
Yes, because it's x squared plus 2x minus, perfect. Good, so we know that we should try to factor the numerator. If you think that x plus 2 or x minus 1 will be factors, because if they are factors, then I have to simplify them. But they will not be factors. So with negative 2, I'm plugging in negative 2 to see, and it's clear it's not going to be 0. And with 1, it's not going to be 0. So even if we factor the numerator, no factor in the denominator will disappear. Because remember, if it does, if I have something like this, over x plus 1, let's say, times x, this simplifies. Function is still not defined there, but this becomes a whole or removable. And the only vertical asymptote is x equals 0. But there is nothing we can do. Even if we factor this, we're not going to get an x plus 2 or an x minus 1. So 2 minus 1, yeah, we do. So there is an x minus 1 here. So what is the factor? Yep, there is one. So how I did this so quickly, then I plugged in, well, I plugged in, I have to plug in 1. No, it's not going to work.
Yeah, I'm pretty sure it's like
no, we don't.
2x.
No, even if, no, no, it's not going to work. So 2x squared minus 2x, it doesn't work. So there is no common factor there. Because see, I have to plug in 1. When I plug in 1, I will not get 0. I get 2 plus 1 is 3. 3 minus 1 is not 0. So x minus 1 is not a factor of the numerator by the factor and the remainder theorem. So there is nothing else. This is it. Okay, so let's find this limit. How do I find this limit? This is very important. What are the steps for finding this limit? Anyone, please. What do we do? What will be the first step? Please, anyone? We are trying to find this limit. Well, we have to plug it in and we get infinity over infinity. And then we have to factor the degree. Can anyone tell us what is the degree in the numerator? Yes, so we have to factor x squared. It happens that they're both the same. 3 factors, 3 terms. I have to have 3 terms. What are those 3 terms? And then, of course, this is my target. That's what I want to do. But I can't do it just yet. Because I have...
It'll be, so the numerator will be 1 plus...
So
2
plus
1 over x
minus
1 over x squared.
Brilliant, very good. And here you're right, it's 1 plus 1 over x minus 2 over x squared. Where are these going? Remember, x approaches infinity. We discussed this. Where are these going?
0.
Yes, of course. So then what is the limit?
2.
Very good. So y equals 2 is a horizontal asymptote. You don't need to calculate negative infinity because this is a pure rational function. It's not a combination with radicals and other things. So now we know that there are 2 vertical asymptotes. So this function has 2 vertical asymptotes. So x equals negative 2 is a VA and x equals 1 is a VA. But we should determine the limits. the limit as x approaches -2 from the left, the limit as x approaches -2 from the right, the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. We should determine these limits because these are VAs because of these limits are infinity or -infinity. Okay? So let's go back. If you want me to show any of these limits, please say so. If not, let's continue. Let me know. So, yes, go ahead, please. Okay, let me know, please. So, do you want to work on any of these limits? Do we want to work on any of those limits?
I want to see like maybe 34.
34, very good. Awesome. Very good. Very good. So let's take a look. Limit as x approaches infinity, e to -x plus 2 cosine 3x. So the problem with this limit, so first, as you know, we have to see what this is. Where is e to -x going? Well, remember, e to -x is 1 over e to the x. If x approaches infinity, this is kind of 1 over infinity. Where will 1 over infinity go? So e to infinity is infinity. Where will 1 over infinity go?
The 0.
Of course. So this piece goes to 0. So that's nothing. Now let's take a look here. The problem with cosine is that it will oscillate between -1 and 1. It will not stop anywhere. So dne plus 0 is still dne. Because no matter where I'm going, the answer from the left and from the right will not be the same. It will be 0.1, it will be 0.2, it will be 0.5, it will be 1, it will be will be back to 0.9 and back to -0.2, -0.5, -1. It will not stop anywhere, so that long enough, if you want, so that both sides are the same. Very good pick. Thank you.
So you're saying anytime we see cosine
At infinity.
at
If I have limit as x approaches pi over 2 from cosine x, the answer is 0. But if I have limit as x approaches infinity from cosine x, is dne. It will never stop. I don't know. It's not approaching anything. It's jumping. Jump, 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 jump. Anywhere between -1 and 1. It doesn't settle anywhere. But here, as x approaches pi over 2 from either side, the function value will be 0. But I don't know what infinity means. What it's not approaching anything, going to infinity. Good, very good question. The one other thing that I was going to, that I have on my agenda, unless you have questions. So let me stop here for a second. F prime of a, f prime of x, and finding the equation of the tangent line for anything that we want to, in connection to these. So these are together. So basically, what I wanted to add here is measurement unit for f prime of x. So be always very careful because it has to have measurement unit for the top over measurement unit of the denominator. That's all I, and look at finding f prime of x or f prime of a. And I don't mind if you are asked to find f prime of a. If you find f prime of x and then you plug it in, it's the same thing. It doesn't matter. So let's choose a function and find f prime of x. And then we'll pick a point to determine the equation of the tangent line at that point. Anyone would like to pick a function? Or we can look at 2.8 and we can pick a function from there. We had many problems, but that we looked at many functions, but if you want to choose another, we can. I will not, for f prime of a, you do whatever you want. You can use f prime of x and then plug it in, or you can just determine f prime of a, whatever works for you. So these are the functions. We had many. I think we looked at 29. We looked at, okay, it jumped again. Sorry about that. We looked at, I remember 27. We looked at this one, which was a lot of work. We had many last time, but you can choose any function you like, or you can create one to find f prime of x and find the equation of the tangent line to the graph at a point. Anyone, please? Because I like to answer more questions if you have anything for me. Anyone?
Can you just go down a little bit?
Yes.
How do you do the like 32?
32, this one? Good.
Yeah.
Very good. So 1 over 1 plus the square root of x. Now let's also pick a point. So let's say when x is 0, y is 1. So two questions here. One, it's asking us to find f prime of x. Number one. And number two, the equation of the tangent line at 0, 1. Make sure that the point is here. Yeah, it is. When x is 0, 1 over 1 is 1. Perfect. So can anyone give us a definition of the derivative? And please do not give me the difference quotient. The definition of the derivative is not the difference quotient. I'm trying to stay straight on two different... Yes. Sorry about that. Go ahead.
Is the limit not as x, or is it the limit as x approaches h, or now h approaches 0?
Yes, that's the only one. From f of x plus h minus f of x divided by h. So this is limit as h approaches 0. We plug in x plus h. Minus 1 over 1 plus the square root of x divided by h. Perfect. Yes, we need the least common denominator in the numerator. Can anyone tell us what is the least common denominator in the numerator? Anyone, please?
The least common denominator or whatnot is 1 plus equal x plus h and 1 plus x.
Yes, it's always the product of the two. Very good. This one up here and this one up here. So 1 plus the square root of x minus 1 minus the square root of x plus h. We distribute -1 to 1 and -1 to the square root. The square root of x minus the square root of x plus h over flip h, 1 plus the square root of x, 1 plus the square root of x plus h. Okay. Now, let's see what happens. When h is 0, the numerator becomes 0, but the denominator is also 0. So I'm still in the situation of 0 over 0. There is still hope. Of course there is. So what do we do next? No one can change this. No one can change this. And this is friendly. How come? Yeah. When h is 0, this is 1 plus the square root of x. No problem. This is the problem. So what do I do? Okay, here's my... Yes. By the conjugate of the... Right.
Of x plus.
Yes, of course. We've done this many times. Thank you so much. Great job. Okay, so this is limit as h approaches 0. This times this will be x, careful now, minus distributed. And the denominator is this, and this. So h, 1 plus the square root of x, 1 plus the square root of x plus h, and the square root of x plus the square root of x plus h. These two go away, luckily, because it has to happen if you remember. If these two don't go away, I'll say, uh-oh, something is not right. Okay. So then we have limit as h approaches 0. The numerator is -h. And the denominator is this whole thing. Finally, the second thing happens, because otherwise I can't determine anything. So it goes away. So then the numerator is -1. The denominator, 1 plus the square root of x, 1 plus the square root of x, the square root of x plus the square root of x, to the square root of x. So to rearrange it a little bit, so now all I want to do